All right, now it's the identity phase, which these are the best because you know what the answer is supposed to be, and it's usually pretty obvious which side to work on, which it looks like it's going to be this one. All right, and the way we want this, again, as I said in the videos of last week, or actually 2 weeks ago since the spring break, um, is we want to go ahead and distribute this. Oh, all right, tan and cosecant do not have a reciprocal relationship. So as I throw that in and show that I distributed that, then you can also turn these into sine and cosine. And hopefully you know that at this point most of the times this works. And if you just think about this one a little bit, with knowing cosecant's 1 over sine, then you can write this like this, minus the tangent distributed. Excuse me. The tangent distributed times, well, it's actually times this sine, which is up here. I always like making it over 1. That's this sign right here, which I wouldn't want that arrow in your work, but just so you know that it's sine times sine in that one. And just put an equal sign. You don't have to keep writing cosine on this side. The idea is you work with one side only until it turns into the other side. And feel free to do that. And then feel free to notice that you have a common denominator. So the next thing you should do is this. Go ahead and subtract them over this common denominator. And then this is 1 minus sine sine, which is sine squared. Then, from your identities, we should know at this point, this is one of our most popular, that this is the sine squared plus cosine squared equals 1 Pythagorean identity. And we subtract sine squared from both sides, and that's equal to cosine squared. And then, of course, one of these cancel, and it always ends with this side is 100% without a doubt turned into this side. And I just let my class do that and say check, which we did last week. Showed that, or 2 weeks ago. Okay, and I know what our first inclinations might be on this one, which might end up working out okay. You know, multiplying, meaning FOIL or distributes and get the 4 multiplications done. Then you'd have to turn tangent squared. Wait, that'd be sine squared over cosine squared times sine squared. Now we get a sine to the 4th. That just seems weird when the right side only ends up being 1. So there's got to be something else. And what it is no one knows Pythagorean identities. Told you that, how important it was to get those memorized. All right? 1 plus tangent squared is actually 100% secant squared. Refer to your little identities there. And then we just had this one last question. 1 minus sine squared is cosine squared. So, oh my gosh, that's so simple. And in my class, I would expect you to write 1 because secant and cosine are 100% reciprocal identities. So we should know that secant squared times cosine squared equals 1. So that's a 2-stepper. If you would have went and foiled this, you would end up getting into a big mess, I believe. And if that happens, sometimes that happens with identities. You have to take yourself back and see if there's another approach. And in this case, there was. That was very, very, very simple. Okay. All right, scroll into this one. This one not so simple. I think all of us would agree that the left side looks like a big, huge mess. And I swear to dog, if you do this and you do that, that is not cats. That is not a cat problem. That is what you came in here with coming into the cat class. You can never, ever cross cancel across a minus sign. That is redonkulous. All right, but anyway, I'm going to squeeze this in here. I think we have been trained when we have these ugly fractions. I didn't want that to be in there yet. It's common denominator. So this side, or this side of the fraction expression, in this case equation, but whatever. Get myself in language problems here. This one's missing a 1 plus cosine. This one is missing a 1 minus cosine top and bottom. All right, now we have a couple problems we have to be aware of here. Number one, I would prefer that you understand we're getting a common denominator, go ahead and multiply one of those denominators and already get the numerators to, be under that common denominator. And these end up being what's called conjugates. So you end up with 1 minus cosine squared. The middle terms fall out. Obviously, that's the same because that was the point. We wanted to get a common denominator. Here, I guess I'm going to change the colors. We want a FOIL, and we are going to end up getting, there's that four-letter F word again, right? Cosine, cosine, that's 2 cosines, or just distributes. You got to know how to do this. We did this in August, man. Too many people not knowing how to do the basics, all right? Things that are holding us back. Before I move into the next one, you must make this plus a negative and distribute it. And then we will FOIL that. So then I can put a plus there. Then you get negative 1. Then negative 1 times negative cosine is cosine, and that's another cosine. So I still get a 2 cosine. Remember these t's here. And then that's a minus cosine squared. Ooh, that numerator got quite extensive there. Okay, so, oh well, we'll have a 2-colored line there. All right, hoi. Okay, so big keys to remember. That's a minus sign. It must be distributed. And then we must know how to FOIL, because that's all that's happening. You stand back and look at that. Oh, that looks complicated. It's not. I just did a couple FOILs and to get a common denominator and just kept track of my signs. And now comes the fun part of why this is going to get simplified. And I keep looking at the right side. Is this going anywhere yet? Let me just relax and see if it is. I like that this happened. That's always a good thing. -1 and +1. That's a nice. Okay. And then I have a 2 cosine t and another 2 there's where the 4 comes in. Okay. 4 cosine t. Interesting. I'm kind of discovering this as I go. Then I think, okay, I got it. I got my 4. This is a cosine. Cotan is cosine over sine. And this is 1 over sine. All right. I know what I need to do. And I already recognize that as well, being our classic Pythagorean identity with sine squared plus cosine squared equals 1. Subtract cosine from both sides, you get sine squared. And then I can break this down. Excuse me, there we go again. Really wanted to impress your teacher, you could break this down into this. This is taking one of the sines and put it over the cosine, and then separating that out with one of the other signs. So that's still sine squared. Sorry for that N being having a hard time writing. I'm a little out of practice in this little breaks that we have had here. But anyway, forgot my equal sign. And then step 4 is to convert it back to whatever the right side is. Or that is what the right side is. So always write. Final step is exactly what the other side is. It's all about the logic in between, though, that we'll be checking. Okay, so tough one, but all it was common denominator and a little bit of algebra with trig. Not a big deal. Then the last one, do something, not what, everybody? Nothing. And what you're supposed to do with that is think about it. You got a subtraction of 2 different angle measures. I got cosine. Hopefully you got it at this point. It's the subtraction rule for cosine we try. So this is adding one of those identities, the subtraction rule for cosine, which is a plus here. Cosine, that the signs are opposite. Little trick thing I remember. And then it's cosine, cosine plus sine, sine. If you're doing your homework, you should recognize this now and say, okay. But then within this identity, we have some what? I have no idea why I hit that. I don't have to write anything here anyway. It's supposed to be negative sine x that we get here. But anyway, and then for this, really what we want is, what is that valuation? And 3 pi over 2 is right chaw. And that coordinate is 0, -1. R equals 1. So cosine is x over r, which is 0. Sine, oh, excuse me, is -1. It's not coronavirus. I'm fine. Been coughing since August. Okay, which probably isn't fine, but that's okay. All right, there you go. Nothing minus sine x or plus a -1 sine x. That means that is negative sine x. And I have found the identity or verified it. Okay, good. And then I always love these last ones. This used to be on a quiz. If we actually, this would have been a quiz question if you guys were back. Um, a student writes this: tangent squared plus 1 equals secant squared. Comment on this student's work. Well, here's my comment: it's bogus, and I can't stand it. This is lazy. This is what I get from students all the time. They don't write what's called an argument right here for you. You don't tan error. You don't tan squared error. You have to have tan squared of, I'm starting to get excited, upset, x. This is lazies when we're checking that work on your identity solving or identity proving. They don't write these, and it's mathematically wrong. It's just not good. So that's the comment on that student's work. Blah. Then this is a classic when I did the notes in my class, and I'm sure all the other teachers said the same, just because we see these errors all the time. Since 1 plus cotangent squared equals cosecant squared, does that mean 1 plus cotan equals cosecant? Heck no. 3 squared plus 4 squared equals 5 squared. That's true. 9 plus 16 equals 25. True. Does that mean 3 plus 4 equals 5? Another new math you've made up. Sounds similar to the 6 over 5 equals 2 math. Wrong. So these are Pythagorean identities that are true. That doesn't make this true when you get rid of the square roots or what have you. So just be careful on that. Some students make up their own identities based off of other ones. Alrighty then.